Hello physics scholars. In this video we're going to do a projectile motion problem, and in doing so you're going to learn how to do projectile motion problems, which are a specific type of physics problem. But I'm also going to be using a problem solving framework which has steps you can apply to any physics problem. So I want you to pay attention to those steps. Alright, so this is a problem from the OpenStax textbook, University Physics. So what I'd like you to do is pause the video at each step, see how far you can take the problem before you get stuck, and then unpause the video and watch some more of it if you need the extra help. Okay, here is the problem. A basketball player shoots at an angle of 60 degrees at a hoop 6.8 meters away. The ball is released 2.0 meters above the floor and the hoop is 3 meters above the floor. What must the initial speed be to make the shot? Alright, the first step in my problem solving framework is read the problem, and I might have to do this several times. And don't try to buffer all the information in your brain at one time. You're reading the problem to get an overview of what you're being told, what you're being asked to find. Okay, so we can tell that this is a projectile motion problem because it involves a basketball shot at a hoop. That's projectile motion if there ever was anything. Okay, step 1, read the problem. Step 2, draw a picture. So I'm going to draw a picture of this basketball player making this shot. So we got a stick figure. And there's the ball, and leaves his hand, follows a trajectory that takes it to a hoop, and he makes the shot. And there's the ground. Alright, so I'm going to define positive and negative direction. I'll call up positive y and right positive x. And so that's a good picture, right? It summarizes the situation. Let me add one more thing. So the initial velocity vector is going to look something like that, and it's at an angle of 60 degrees relative to the horizontal. All right. Now let's write down what we know and don't know. So I read the problem, I drew a picture. Let's write down what we know and don't know. So what I'm going to do is make some space on the page to write this stuff down, but separate it in terms of x and y components. So a strategy for projectile motion is break the problem into horizontal component and a vertical component, and treat it as two separate problems. All right. So in the x direction, the things we know are initial position, final position, the acceleration in the x direction is 0 meters per second squared, because there's no forces in that direction. And that's it. The things we don't know the initial velocity or the final velocity in that direction, but we do know that they'll be equal because there's no acceleration. And we don't know how long it takes for the ball to travel from hand to basket. All right, in the y direction, we know the initial y position is 2 meters off the floor. The final y position is 3 meters off the floor. The acceleration in that direction is negative g, which is negative 9.8 meters per second squared. Negative because gravity pulls down, and we said down is negative in this problem. What don't we know? We don't know the initial velocity, we don't know the final velocity, and we don't know how long the ball is in the air. Okay. So, read the problem, draw a picture, include defining positive and negative direction in your picture, write down what you know and don't know. So in this case, we've done this by writing down stuff that we know in the x direction and stuff we know in the y direction. We've broken the problem into two parts. The next step is find the physics that connects what you know with what you don't know. All right, so ultimately we're trying to find the initial speed of this ball. All right, so we know that x equals x naught plus the initial velocity in that direction times t plus 1/2 ax t squared. And this last term will be 0 because ax is 0. So let's see, what do we know in this equation and what don't we know? Well, we know our final and initial positions, but we don't know these two factors, so we can't solve for this. So let's change over to the y dimension and see what we get over there. Let me write out the same equation in this dimension. And let's see, what do we know? And what don't we know? We know initial and final y position. We know the acceleration in the y direction, but here, again, there's two things that we don't know, t and initial velocity in the y direction. So we are, this turns out to be algebraically a challenging problem. It appears that there is no equation that we can solve by itself. There's no in order to solve an equation, one of these kinematic equations of motion for an unknown, there can only be one unknown. So you can't solve it if there's more than one unknown. But in algebra you learn, well, if you can combine equations in some way, if you have two unknowns, you need two equations to solve those unknowns. Here we have three unknowns. So let's write down a third equation that might be a way to combine these equations and get rid of the unknowns. So to do this, let's take a closer look at this initial velocity vector. Okay. And we learned that when you have two-dimensional velocities, two-dimensional vectors, you can break them into x and y components using trigonometry. So you add the x and the y together, tip to tail, and you get the whole thing, v naught. And trigonometry tells us that the sine of that angle equals the magnitude of the opposite side, which in this case is v naught y, over hypotenuse. And the cosine of that angle equals adjacent over hypotenuse, which is the magnitude of the x component over v naught. And so what we see here is, let's solve this for v naught x and v naught y. So we get v naught y equals v naught sine of 60 degrees, and v naught x equals v naught cosine of 60 degrees. And then let's take these expressions and substitute them in the appropriate place and see what that gives us. X equals x naught. And actually, let's just get rid of x naught because it's 0. And we get x equals, to v naught x, let's write it as v naught cosine of 60 degrees times time. Okay? And for the y equation, we'll get y equals y naught plus, instead of v naught y, we'll write v naught sine of 60 degrees times t plus 1/2 ay t squared. And now let's solve for v naught over here. And then plug that in for v naught over here. And we'll get y equals y naught plus x, we write it like this, sine 60 degrees over cosine 60 degrees t divided by t. So the t's cancel, plus 1/2 ay t squared. And what we have now is an equation where we know y final, y initial, x final, ay. So the only thing in this equation we don't know is time. So we can solve for it. Okay. So at this point, let me fill you in on a little bit about my thought process here. For a time, when I start writing down equations, I'm just proceeding algebraically, almost organically through the process of trying to find an unknown. And at some point, I lose track of the actual unknown that that the problem wants me to find, because I'm on the trail of something. All right, in this case, I'm looking for time. So the path that unfolded before me leads me to a formula now that I can use to solve for time, how long the projectile is in the air. And I know that by finding an unknown, I'm moving in the right direction, even if the unknown I find at this point isn't ultimately the thing that the problem wants me to find. Okay? But I know that I'm on the right track. All right? So my process might not be the most direct path to the solution that the problem wants me to find, for the unknown that the problem wants me to find, but my process is leading me in the right direction. Okay, so now I can solve for time. T equals y minus y naught minus x, sine over cosine is tangent of 60 degrees, multiplied by 2 divided by a sub y square root. And when I plug in my, zoom out here, when I plug in what's known from up here, down here, I get t equals 1.48, one more decimal place, 3 seconds. So this is how long the basketball is in the air. Okay. And what I find now is, wow, once I have this, it's a straight path to v naught. Because now I have this, and I have x, how far the ball travels, so I can solve for v naught. And when I do that, I get v naught equals 9.17 meters per second. And I'm done. This is the answer that the problem wants me to find, the initial velocity. What must the initial speed be to make the shot? Speed is the magnitude of the initial velocity. 9.17 meters per second. Okay, so let's recap. So here I'm showing you how to find the solution to a specific type of physics problem, a projectile motion problem, which involves kinematic equations and kinematic quantities in 2 dimensions, x and y, horizontal and vertical. And so there's some specific strategies I used here, like breaking the problem into 2 dimensions, x and y dimension, understanding that time is the glue that time is the thing that glues the two dimensions together. All right, so these are specific strategies to projectile motion problems, but in the background is a framework, a series of steps that I can take that apply more generally to other types of problems as well. And so let me summarize the steps that I took here one more time. So step one was read the problem. All right, I'm trying to get an overview of what I know, what I don't know, and what type of physics is going to be involved in studying this problem. Read the problem. Step two, draw a picture. And the picture should include a definition, a statement of what I mean by positive and negative direction. All right, because we're dealing with vector quantities. Step three, write down what I know and what I don't know. And here you're translating words on the page into algebraic symbols, using symbols like v0 to represent initial velocity and v0y to represent the y component of the initial velocity. Step four, find the physics that connects the knowns with the unknowns. So it's not unusual to have more than one unknown, and my process is, let's just start writing down physics formulas in the domain of the problem, which in this case is kinematics, and let's see where it leads us. And for me, it led us to a solution for time, how long the basketball's in the air. And even though that wasn't ultimately the thing that I was trying to find, it was it directly led me to that thing I was trying to find, the initial velocity. Step five, solve. Find your solution. Do the algebra. All right, I could add one more step here, which would be to check. Go back and check. Make sure your answer makes sense. Does it have the right units? Does its magnitude seem reasonable? Is there, you might even see if there's another way that you can navigate through the problem to find the same solution. And if you do the problem twice in two different ways and you get the same answer, that's pretty strong support that you did it right. Okay, so that's it for this problem, and I'll be posting more.